Assalamu alaikum to everyone. Dear students, welcome back to our educational program Amader Pathshala. Hope you all are doing great by the grace of Almighty Allah. I am here to take the general mathematics of class 10. Let's see what is our today's topic. So our today's topic is exponents and logarithms of chapter 4. After ending of this chapter, you will be able to learn about rational exponent, explain and apply the positive integral exponents, zero and negative exponents, solve problems by describing and applying the rules of exponents, explain the nth root and to solve nth root related problem. I hope all of you have a little bit idea about exponents from your previous classes. So what is an exponent? An exponent is a number or letter written above to the right of a mathematical expression called the base. It tells us how many times to use any number or letter in a multiplication. So if you have the base a and x is the exponent or power or index, you have an exponential expression like a to the power x. See here, x is index or exponent or power, and this a we call it base. Say you have any real number a. If you multiply this a by 2 times, you will get a square. If you multiply a by 3 times, you will get a cube. And similarly, if we multiply a by 4 times, you will get a to the power 4. These 4, this 3 and these 2, they are telling you how many times you have to multiply these a together, right? And similarly, if we multiply a by n times, we will get a to the power n. And here a is your base and n is your exponent. So the base is the number or letter that will get repeatedly multiplied together, and the exponent, it actually tells us how many times to repeat that number. If we see that 2 to the power 5, here your exponent or power is 5, and this tells us we have to multiply these two by 5 times. In our next slide, you will see some properties of indices. Let a belongs to R, that is a is a real number, and mn belongs to n, where n is the set of natural numbers. So our first rule is laws of multiplication, a to the power m into a to the power n equal to a to the power m plus n. That means when you have the same bases here, that is a and a, they are same, so we have to add their powers like a to the power m plus n. Let's see an example. We have 2 to the power 3 into 2 to the power 5 here. So, we will get 2 to the power 8. How can we get them? By adding this power 3 and 5. Next law is our laws of division. We have a to the power m divided by a to the power n. And since here in our numerator and denominator we have the same bases, so we have to subtract their power, that is a to the power m minus n. And see, I have written a condition here, that is m is greater or equal to n, because if m is greater or equal to n, we will get the answer in a positive way. So, let us see an example here, 3 to the power 7 divided by 3 to the power 4. So, this base 3 and 3, they are same. So, we have to subtract their power, that is 7 minus 4, we will get 3 cube. Let us see our next formulas. This is power of product. If we have two factor like AB whole to the power n, you have to distribute this power n between these two factor, a to the power n into b to the power n. Let us see an example. 2 into 5 to the power 5 equal to 2 to the power 5 into 5 to the power 5. And our next law is laws of quotient. That is, if we have a fraction like a over b whole to the power n, and in this case you have to also distribute this power n in between them, like a to the power n divided by b to the power n. And see, I have written a condition here, that is b cannot be 0. If we put b equal to 0 here, it will be undefined. That is why you have to avoid to put 0 in our denominator. Let us see an example. Here we have 5 over 2 whole to the power 3, and according to this formula, we have to distribute this power 3 in our denominator and our numerator, that is 5 cube divided by 2 cube. And we have our next law, that is laws of power. Say we have an expression like a to the power m and whole to the power n. If we have an expression like this. In this case, you have to multiply the power together, that is a to the power mn. Let us see an example. 3 to the power 4 whole square equal to 3 to the power 4 into n, and you will get 3 to the power 8. Let us see our next formula, which is called zero index. That means if we have a to the power 0 equal to 1 and a is not equal to 0, this is the condition, because if you put the base as 0, you will get an undetermined form. So, you have to avoid to put 0 as base. So, you can prove it in a simple way. See, in our right hand side we have 1. So, we know actually if you divide something by itself, that you will get 1. So, we can write it a to the power n divided by a to the power n. Not only a to the power n, you can take any number like a square or like a to the or divided by a square, or 4 square divided by 4 square. And since bases are equal here, and according to our laws of division, so we can subtract the power, that is a to the power n minus n. It will give you a to the power 0, and which is your left hand side. And see, let us see an example, that is 2 to the power 0, it will give you 1, 1 by 2 whole to the power 0, it will also give you 1, minus 3 to the power 0, it will give you 1, p to the power 0, this is also give you 1. Negative index, and this is the most important formula of this chapter. So, a to the power minus n equal to 1 by a to the power n, and we can prove it in a simple way. See, in our right hand side we have 1 by a to the power n, and from our previous formula, that is zero index, we can write a to the power 0 instead of 1, and since bases are equal here, so definitely you can apply laws of division, that is a to the power 0 minus 1, and it will give you a to the power minus 1, which is your left hand side. So, this is the proof, is this negative index. And now, the nth root of any number or nth root of a, if we multiply 2 by 2 times, then you will get 4, that is 2 square. And to get the original base or 2, you have to take square root of this 4, that is square root of 4 will give you 2, right. And then we have 2 cube equal to 8, that means if you multiply 2 by 3 times, it will give you 8, and to get the back 2 or original one, you have to take cube root of this 8, that is cube root of 8 equal to 2. Similarly, see, we have 2 to the power 4, it gives us 16. So, if you want to get back the original one, that is 2, you have to take 4th root of 16, that is we will get 2. And similarly, if we have 2 to the power 5, so to get the back one, that is 2, we have to take the 5th power of this 32, we will get 2. So, we can say that this power or this base exponent, that tells us and which root we have to take it, we have to take. So, if we have b equal to a to the power n, or we can say that if we multiply a by n times, then we get b equal to a to the power n, and if you want to find this a, so you have to take the nth root of this a. So, a equal to b to the power 1 by n, or we can write it like this symbol, nth root of b. So, we can say actually nth root of a equal to 1 by n, or 5th root as 1 by 5, or 4th root is 1 by 4. Let us see an example. Here we have an expression like cube root of 7 square into cube root of 7 divided by square root of 7, and according to our nth root, we can write cube root as 1/3. So, it becomes 7 square whole to the power 1/3 into 7 to the power 1/3, and according to our laws of power, we have to multiply them together, then it will become 7 to the power 2 by 3 into 7 to the power 1 by 3. And if we add them, since bases are equal here and there is a multiplication sign, so definitely you have to add their powers. So, it will be 7 to the power 2 by 3 plus 1 by 3, and here we have as well 7 to the power half, which is our denominator. And if we add them, so I hope you all know about how to add fractions, right? So, it will give you 7 to the power 3 by 3, and if we cancel out, you will get 7. So 7 to the power 1 divided by 7 to the power half, and since bases are equal here, so you have to subtract their power, that is 1 minus half, and it will give 7 to the power half, which is actually root over 7. So this was an example related to our nth root. Let us see about some important formula of this chapter. So under the condition a is greater than 0 and a is not equal to 1, if a to the power x equal to a to the power a, then x equal to y. That means if you have same bases in an equation on both sides, then you can remove them. So by removing them, you can write power x and y, they are equal. But please look at the condition that a cannot be 1. A cannot be 1. Why a cannot be 1? Because if you put 1 here, 1 also here, then we always get only 1, because 1 to the power 1 it gives you 1, 1 to the power 100 it also gives you 1. That's why we will avoid 1 here. So in this case we can say that if bases are equal in an equation, then their power also should be equal. And formula number 2, under the condition a is greater than 0 and b is greater than 0, x is not equal to 0, then if you have a to the power x equal to b to the power x, that means you have the power as equal, then we can write a equal to b, then a equal to b. So look at the condition that x cannot be 0. Why x cannot be 0? You already know about 0 index, right? If you put 0 here and also 0 here, you will get always only 1. That's why we avoid x0 as index or power. Let's see an example related to this. So solve 2 to the power 2x plus 1 equal to 128. In our right hand side we have 128, and if we can express 128 as 2 to the power 7. See, bases are equal here, here is also 2, here is also 2. That means we can remove them. So our power, they will be equal. So 2x plus 1 equal to 7, right? And 2x equal to 7 minus 1 by applying transposition law, and 7 minus 1 it will give you 6, and by divided both sides by 2 you will get 3, and the solution of this math is x equal to 3. Let us see some problem where we have a problem like 2 to the power n plus 4 minus 4 into 2 to the power n plus 1 divided by 2 to the power n plus 2 divided by 2. So you can calculate this math or solve this math simply using laws of exponent. In our second line, see, we have 2 to the power n into 2 to the power 4. How we have used them? Because we have a to the power m into a to the power n equal to a to the power m plus n. So we have used this formula. So 2 to the power n into 2 to the power 4 minus 4 into 2 to the power n into 2 to the power 1. And see, in our denominator we have a division sign. So definitely you can subtract their power. So 2 to the power n plus 2 minus 1. And in our next line we can take 2 to the power n as common, and then we will have 2 to the power 4 minus 8. 4 into 2 it will give you 8, and here after addition and subtraction you will get only n plus 1, 2 to the power n plus 1. And in our denominator we have 2 to the power 1 n plus 1, so we can write it as 2 to the power n into 2, and by cancelling this 2 to the power n from denominator and numerator you will get 8 by 2, which will give you 4, and this is the answer of this math. Let us see our what is our in our second problem. So in our second problem we have x to the power a divided by x to the power b whole to the power a plus b into x to the power b divided by x to the power c whole to the power b plus c into x to the power c divided by x to the power a whole to the power c plus a equal to 1. You have to prove that. So let us write what is in our left hand side. So in our left hand side, x to the power a divided by x to the power b whole to the power a plus b into x to the power b whole divided by x to the power c whole to the power b plus c into x to the power c divided by x to the power a whole to the power c plus a. And inside this bracket we see that we can use there the laws of division, right? So that means we have to subtract the power, that is x to the power a minus b whole to the power a plus b into x to the power b minus c whole to the power b plus c, x to the power c minus a into x to the power c minus a whole to the power c plus a. And see, And now we can apply the laws of power. That means you have to multiply these two powers together. So if we multiply them, we have a plus b into a minus b, which is the formula of a square minus b square. So definitely you can use a product here like a square minus ab minus plus ab and minus b square, and or directly you can use this formula. And similarly in other two factors, that is x to the power b square minus c square into x to the power c square minus a square. And since bases are equal here, see x, so we can definitely, and multiplication signs among them, so we can definitely add their power, that is a square minus b square plus a square b square minus c square plus c square minus a square. And if we cancel them out, you will get x to the power 0, which is equal to 1, and this is equal to right hand side. And let us see a creative question. If we have p equal to x to the power a, q equal to x to the power b, and r equal to x to the power c, the first question is find the value of p to the power bc into q to the power minus ca. And question number b is find the values of p by q whole to the power a plus b into q by r whole to the power b plus c divided by 2 into rp whole to the power a minus c. And in our question number c, we have shown that p by q whole to the power a square plus ab plus b square into q by r whole to the power b square plus bc plus c square into r by p whole to the power c square plus ca plus a square equal to 1. Let us see the solution. So here we have p equal to x to the power a and q equal to x to the power b. So given expression is p to the power bc into q to the power minus ca equal to, we can put the values of p of q here. So x to the power a whole to the power bc into x to the power b minus ca, and we can multiply them a b into bc. So we will get x to the power abc into x to the power minus abc, and since bases are equal here, so we have to add them. So we will get x to the power abc minus abc here. After cancelling them, you will get x to the power 0, and it will give you 1, which is the answer of this question. And let us see which is in our second question. In our second question, we have a given expression and we have to find the value of this. So given p equal to x to the power a, q equal to x to the power b, and r equal to x to the power c, and we have a given expression. So we can use the value of p, q and r in these places. So if we put p equal to x to the power a, q equal to x to the power b, and r equal to x to the power c, then we will get x to the power a by x to the power b whole to the power a plus b into x to the power b by x to the power c whole to the power b plus c divided by 2 into x to the power c into x to the power a whole to the power a minus c. And now we can use laws of division, that is x to the power a minus b whole to the power a plus b into x to the power b minus c whole to the power b plus c divided by 2 into x to the power c plus a whole to the power a minus c. And if we multiply these two powers, we will get x to the power a square minus b square into x to the power b square minus c square divided by 2 into x to the power a square minus c square. And since there is a multiplication sign between them, so we can add their powers. So we can get x to the power a square minus b square plus b square minus c square divided by 2 into x to the power a square minus c square. And if we cancel them, then we will get x to the power a square minus c square and divided by 2 into x to the power a square minus c square. So we can cancel it directly, or you can subtract their base, subtract their power also. So half into, if we subtract their power, we will get x to the power 0, and x to the power 0 it will give us 1. So half into 1 equal to half, and this is the answer of this question. Let us see what is in our question number C. In our left hand side, we have this expression p by q whole to the power a square plus ab plus b square into q by r whole to the power b square plus bc plus c square into r by p whole to the power c square plus ca plus a square. And we already have the values of p, q and r, p, q and r. So let us put the values of p, q and r here. After putting these values, we get an expression like x by x to the power a divided by x to the power b whole to the power a square plus ab plus b square into x to the power b divided by x to the power c whole to the power b square plus bc plus c square into x to the power c divided by x to the power a whole to the power c square plus ca plus a square. And inside this bracket C, we have the laws of division, so we can subtract their power. So x to the power a minus b whole to the power a square plus ab plus b square into x to the power b minus c whole to the power b square plus bc plus c square into x to the power c minus a whole to the power c square plus ca plus a square. And you can see that here we have two powers like x to the power a minus b and whole to the power a square plus ab plus b square. So, we know what to do, we have to multiply them together. So, if we multiply them, we get x to the power a cube minus b cube. See, there a minus b into a square plus ab plus b square, this is the formula of a cube minus b cube, we already know it. And we can directly use this formula into x to the power b cube minus c cube into x to the power c cube minus a cube. And see we have same bases here and multiplication signs among them. So, definitely we can add their powers together. So, it will give you x to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. And if you cancel out them, then you will get x to the power 0, which will give you only 1. So, this is your right hand side. So, let us see, we have a creative question too. And what is the question here? See, x equal to 2 to the power a inverse plus 3 to the power 3 into b inverse whole to the power inverse 1, y equal to p q root of x to the power p divided by x to the power q, q r root of x to the power q divided by x to the power r, and rp root of x to the power r divided by x to the power p. And you have an expression of z like this: 5 to the power m plus 1 divided by 5 to the power m whole to the power m minus 1 divided by 25 to the power m plus 1, 5 to the power m minus 1 whole to the power m plus 1, and where x, p, q, r, all of them are positive. Okay. So, that means we have these three expressions x, y and z, and we have three questions like number A, find the value of x, you have to find out this value from this expression. Show that y plus 4th root of 81 equal to 4, and number C, show that y divided by z equal to 25. Let us see the solution. Question number 1, we have x equal to 2 to the power a inverse plus 3 inverse b whole to the power minus 1, and this a inverse, this is our negative index, so we will get 1 over a. So, 2 into 1 over a will give you 2 by a plus, and similarly b inverse means 1 over b, and 3 into 1 by b, that it will give you 3 by b whole to the power minus b. So, see, in this bracket we have two fraction 2 by a and 3 by b. So, how to add them, we already know it. So, we can take LCM, our LCM is ab, so we will get 2b plus 3a whole to the power minus 1, and again if we apply the negative indices here, then we will get 1 over 2b plus 3a divided by ab, and if we multiply them with 1, then we will get ab by 2b plus 3a, because there is the division sign, and we all of you know that division is the inverse operation of multiplication. So, ab by 2b plus 3a, this is your answer. Let us see what is in our question number B. In our B, we have y equal to p q root of x to the power p divided by x to the power q, and into q r root of x to the power q divided by x to the power r, into r p root of x to the power r divided by x to the power p. And we can write it as x to the power p minus q, since bases are equal here, so we have to subtract their power, and p q root means 1 by p q, similarly of nth root, and into qr root means 1 by qr, and we can subtract their power also. So, x to the power q minus r whole to the power 1 by qr into x to the power r minus p whole to the power r by 1 by rp. And in our next line we can multiply these two power together. So, it will be x to the power p minus q divided by pq into x to the power q minus r divided by qr into x to the power r minus p divided by rp. And since bases are equal here, so definitely we can subtract we can add their powers. So, we have x equal to p minus q by pq plus q minus r divided by qr and r minus p divided by rp. And if we add them together, then we will get, and their LCM is PQR, and in our denominator we will get an expression like this, here RP minus QR plus PQ minus RP plus QR minus PQ, and if you cancel them out, then you will get x to the power 0 by PQR, and which actually x to the power 0 and equal to 1. And let's in our left hand side we have y plus 4th root of 81, and from our previous slides we have y equal to 1. So, if we put y equal to 1 plus and 81, we can write it as 3 to the power 4, and this 4th root we can express it as 1 over 4, and after if we multiply them we will get only 3. So, here 1 plus 3 equal to 4, and which is in our right hand side. Let us see what is in our question number C. So, in question number C we have z equal to 5 to the power m plus 1 divided by 5 to the power m whole to the power m minus 1 divided by 25 to the power m plus 1 divided by 5 to the power m minus 1 into m plus 1. So, in this math we can apply to first fraction. In their denominator we can multiply these two power together, that is 5 to the power m square minus m, and in our second fraction in this numerator we can write 25 as the product of prime factor, that is 5 square and whole to the power m plus 1, and we can apply m plus 1 into m minus 1, which is the formula of m square minus 1. And then in our third line we have just calculated this part or this numerator of the second fraction, that is we have multiplied this 2 power 5 to the power 2m plus 2. And then since bases are equal here and there is a division sign, so we have to subtract their power, that is 5 to the power m plus 1 minus m square plus m divided by 5 to the power 2m plus 2 minus m square plus 1, because you know if we divide something multiply something by minus 1, the sign changed, and then we can addition and subtraction here. So, we have 5 to the power 2m minus m square plus 1 and divided by 5 to the power 2m minus m square plus 3, and since bases are equal here also and there is a division sign, so we can subtract their power, which is to f 5 to the power 2m minus m square plus 1 minus 2m plus m square minus 3, and it will give you a 5 to the power minus 2, and which is actually 1 over 5 square according to our negative index. So, it will give you 1 by 25. And now in our left hand side we have y divided by z, and and we have from B we have y equal to 1, and in our previous slide we have discussed that the value of z is 1 by 25, and if we get this operation then we will get 1 into 25, which will give you 25, and this is the right hand side of the which is the right hand side. And then, so dear students, enough for today. Next enough for today. Stay safe and stay home, stay safe. Assalamu alaikum.